I am Mr. Ish and I welcome you to this video. We're looking here at a special type of trigonometric integral form. There are a few types. We're only looking at one of these forms. In this video, we can look at some more in future videos. If you think back to trigonometric identities, there's a specific identity which takes this form right over here, and this right here is the one which is identified as there's the product to sum formula or product to sum identity. And you've seen something like this if you think back to your trigonometry class. It's not one of those very widely known identities because some instructors choose to skip it altogether, but it is an identity out there and it can easily show up as an integrand in a question. If you have this one, you use a product to sum formula, and the formula is something like this. You have something which looks like this. Imagine you have something which look like sine 2x and cosine 3x. And how would you relate that with regards to an identity? Well, that's where this product to sum formula comes in. You have something which looks like a minus b, sine of a minus b plus sine of a plus b, and that right there would be how you would handle that with regards to this identity. Why is this called product to sum formula? Because you have something which starts out as a product and it gets converted into a sum. There's a product relationship right here, and then there's a sum developing out of that, and that's exactly why it is this, and that's exactly how you would handle something like this. If you were to look at this, you would very easily identify that you're looking at a product, and you would bring in this product to sum identity. When you look at something like this, all of this would become right over here. If you wanted to be extra clever, you can, and bring the 1 over 2 out. And now the product to sum formula or identity has been brought into a integral of this form. This integrand is not easy to compute. You can using integrating by parts, but it can become very, very messy. Using this form right here simplifies it greatly. This right here is your a, this here is b, and everything falls right here. Notice you have a sine and a cosine, but your answer in terms of this integrand form will only have sines. But when you do the antiderivatives, cosines will come into play. I want to show you examples of this form for this particular video, and let's do it. Let's take this little form over here and we'll put it here as our guide. You can choose to remember this if you want, or you can put it on one of your reference cheat sheets and you can utilize them as you need to. But that right there is our identity, and that's the guide which will guide us through here. You have a question which looks something like this. Let's look at easy one first. Sine 2x cosine x dx, and this is exactly a product. Here a is equal to 2, b is equal to 1. The coefficient of this is a 1. You have a and a b. You're going to look at it exactly as you're seeing it in terms of this template. You'll have a sine a minus b, 2 minus 1. You'll have an x plus sine a plus b, 2 plus 1. You have a 3x and then dx, and that guides you to completion. You can do separation of everything over here. 1 over 2 integral sine x dx plus 1 over 2 integral sine 3x dx. Everything here is easy except for this. Not hard, but you have to do polynomial substitution. If you do all of this, you're getting a minus 1 over 2 cosine x. That is done. Here you do u is equal to 3x, du is equal to 3 dx, and dx is equal to du over 3. When you bring all of this 1 over 2, 1 over 3, you'll get a 1 over 6, and then you're looking here at a sine u du. Okay, now you just have to finish this, and we'll finish it for you right over here. When you do this, you're gonna get a minus 1 over 6 cosine u, but you will resubstitute for 3x, and that's exactly what's gonna come right over here. And allow me to bring the finalized antiderivative for you right here. Minus 1 over 6 cosine 3x plus c. This right here is my antiderivative of that. It's an indefinite integral, but you see how the procedure comes about. How about we look at two more of these type of forms, and then that should be it for this particular special type of trigonometric integral. Our integral is this. Integral sine 3x cosine 4x. Here a equals 3, b equals 4. Let's do it. You have 1 over 2 coming out. You're doing sine of a minus b. 3 minus 4, you're getting a minus x. That's alright, you can get a minus x. Then we have a plus, and then a sine 3 plus 4, a plus b, which is 7x dx. Sine is an odd function. You can bring this minus right out here, park it out. You have minus 1 over 2, you're looking at integral of sine x dx. plus 1 over 2 integral sine 7x dx. Let's expedite everything over here. When you do the antiderivative of this, you're bringing a minus cosine, it'll cancel out that. You'll have here a positive 1 over 2 cosine x. When you're doing the antiderivative of sine, you're bringing a minus cosine, you'll have a minus. You'll have a polynomial substitution, u is equal to 7x, du is equal to 7 dx, dx is equal to du over 7. That 7 will multiply with this. You'll have 1 over 14. Or cosine u, resubstitute, and that right there would be your antiderivative. You can combine here under common denominator if you want, or you can leave it as this. But this right here is your antiderivative. Cosine x over 2 minus cosine 7x over 14 plus c, and the question has been solved. This template makes it quite easy. This here represents our last one. We have over here integral sine 3x cosine 3x dx. A is equal to 3, b is equal to 3, and let's see how things will play out, because we have a minus b will develop as 0, but that's fine. Bring everything into the form. We have a sine 3 minus 3, well, that's a 0x. You know sine of 0, that's going to be a 0, plus sine 6x dx. 0x is meaningless, sine of that is meaningless, you can have a 0 come out of that. Then you really have 1 over 2 integral sine 6x dx. Polynomial substitution, u is equal to 6x, and you know everything from there. Antiderivative of sine is a minus cosine. You'll have a minus cosine 6x plus c, and you know you'll have over here a 1 over 2 times 1 over 6, you'll have a 12. You could have written as minus 1 over 12, then you can do cosine 6x plus c. Either way, it's fine, but you see what's going on over here. We lost one term simply because a and b were the same. So in this first part, a minus b became a 0. We lost this term right over here. But you have seen this special form of trigonometric integral is this form, sine a cosine b. There are other forms. You can have a form where you just have sine a and sine b, where both are sine. You can have a form where both are cosines, so we have to look at those two forms. But in this video, we're looking at this particular form, and you handle it by this particular means. For clarity's sake, we can even put a parentheses right over here, so all of this is understood to be affected by this integral and the 1 over 2 sitting outside. And that's it for this video. I hope you enjoyed it. Have a great night. Bye.